The third part here is about big models. And so neural networks are interesting. They go back into the 40s with McCullough and Pitts at MIT. But again, it took a long time before we really had enough compute power for neural networks to take off. And so in 2006, Jeff Hinton published a paper about having layers and layers of neural networks stacked on top of each other using a thing called an autoencoder in between every layer. And they could do magic with it. They just didn't have the right data for that to really show it off. It took them 7 years to find the right data set. But in 2013, they published a paper that took ImageNet data, a bunch of images, and ran them through deep neural network structures. And one of the grad students was Alex. He has a Russian name, and I apologize, I can't pronounce it. But he put some code on GitHub called AlexNet. And it was basically a way of taking ImageNet, running it through a deep neural network. And interestingly, he also added the option that you could use GPUs, graphical processing units. You could use GPUs to make the thing run much, much faster. And he made that all open source on GitHub. And from 2013, that just took off. I have a friend here in DC who had the first DARPA contract for defense-related use of deep learning. And it was a two-person company, and they did the challenge at DARPA for like F-16 fighters for incoming target, whatever identification. They were able to apply deep learning on that data set with all these huge defense contractors competing, and they were able to beat out the closest competition by 25x. And we've seen this down the line, that deep learning has some really amazing consequences. And so that all started in 2012. It'll take about 12 years to be commodified. That gets us into the mid-2020s. So we're seeing interesting things with the big models right now.